Hi, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 10, and for this week, we are going to explain about the Experiment 7, Torricelli Theorem. Now, our group leader for this week is Nurul Fiona Adrina binti Muhammad Zahari, and our group members are Wang Runli, Bavin Raj anak lelaki Sugumaran, and me myself, Nurul Batrisha binti Bahar. So, I will start this presentation with abstract. So this experiment is to examine the Torricelli's relationship. It will be achieved by taking the reading of maximum distance of the water and the time taken for the water to drain out. So after taking the reading, the velocity of water can be calculated by using the Torricelli's theorem. Next, the objective of this experiment is to verify Torricelli's relationship by comparing measured and theoretical value of velocity. So, Torricelli's law has a practical application in daily life. This law describes an important relationship between fluid exit velocity and the height of fluid in the container. So, in this experiment, the cylindrical cylinder is placed in a various of height and the different reading of maximum distance and time taken is obtained, which is we have 3 different height. And there's another ways of experiment to test Torricelli's law, which is by using a soda bottle with a small hole at the bottom. So students need to understand about the relationship between the height and the velocity of the water to achieve the objective of this experiment. So next for theory, I will pass our presentation to my friend.
Hi everyone. For this week, I will be explaining about the theory for this experiment. Torricelli's theorem is a statement where the speed v of a flowing fluid or flowing liquid under the force of gravity out of an opening in a tank is proportional jointly to the square root of the vertical distance, that's h, between the liquid surface and the center of the opening, and the square root of twice the acceleration caused by gravity, that's 2g. Or simply, the Torricelli theorem is equals to v is equals to square root of 2gh. The theorem is named after Evangelista Torricelli, who discovered it in 1643. So, Torricelli's law derivation. So, assuming that the fluid is compressible, Bernoulli's principle stated that v square over 2 plus gh plus p over rho is equals to constant, where the v is the speed of fluid and g denotes the gravitational acceleration, and h shows the liquid's height over the reference point, and rho, as always, is the density, and P is the atmospheric pressure at the top of the container, and V is considered as zero because the fluid surface drops in height slowly compared to the speed at which liquid leaves the tank, and H is equals to 0 and P is the atmospheric pressure at opening. H is equals to 0. So as we all know, when we compare 2 points where point 1 and point 2, so according to the Bernoulli equation, so we can produce another equation, that's P1 plus half rho V1 square plus rho G H1 is equals to P2 half rho V2 square plus rho G H2. So, and we simplify the equation. V2 square is equals to 2g h1 minus with h2 and plus 2 in bracket multiply, that means 2 multiply with p1 minus p2 over rho. So as we all know, h1 minus h2 is equivalent to the height of the liquid surface over the opening p1 and p2 are typically both atmospheric pressure. So as we know, p1 and p2 we denote it by h, and p1 and p2 are atmospheric pressure, where p1 and p1 is equals to p2, where p2 is equals to 0. So p1 also will equals to 0. So finally we will end up with v2 square is equals to 2gh, or v square is equals to 2gh. So now our v would equals to square root of 2gh. That's how we get the Torricelli theorem. So I'll pass it to my friend.
Good evening, everyone. My name is Runli from Group 10. So right now I'm going to discuss about the methodology of the experiment 7. Okay, without further ado, let's jump straight into the main point. Okay, so for this experiment, the procedure and the setup actually is quite not that complicated compared to the previous experiment. Okay, so right now I'm going to explain about it. Okay, so for the first step actually is the setup. So we actually set up the experiment based on 3 different heights. So they are H1, H2, and H3. Okay, so for each and every time we doing the experiment, the reading for the height is different because it depends on the water level. Okay, so basically this is the setup for the H1 height, and then this is for the H2, and then lastly this is our H3. Okay, so for the second step is we actually fill up the cylindrical tank with 2 liters of water, and then of course at the same time we actually cover the hole at the bottom of the cylindrical tank, so to stop the water from flowing up. Okay, so there are several pictures to show you right now. Okay, so this is the picture on how we fill up the cylindrical tank with water. And then the second picture is actually showing that how we cover the hole of the cylindrical tank. Okay, so after that, we actually take off our fingers from the hole and let it run. Okay, after our fingers was taken off, and then the water will flow out from the hole. So at this moment, we will calculate the maximum distance was marked by using the clay, and the time was also recorded by using a stopwatch. Okay, so these are several pictures that I can show you. Okay, so this is the picture that the water actually flowing out from the hole of the cylindrical tank. So after that, we record the furthest distance traveled by the water. Okay, so this is a very important reading. And then lastly, this is the stopwatch that we can show you to record the time. Okay. And then step 4, actually not the last step, but actually the conclusion and summary of the procedure for the experiment. Okay, so the procedure generally was repeated by using different volume of water, and at the same time we also using different height of stages. Okay, so like just now I told you that we actually initially use 2 liters of water for filling up the cylindrical tank, but for the second time we actually use 1.75 liters. And then for the next experiment, we repeat by using 1.5 and then 1.25 and then lastly 1 liter of water. Okay, actually, or you can call it as meter cube as you like. It's okay. And then at different heights of stages. Okay, so for the first time we do is we use H1 and then second time H2 and then so on H3. So actually we are using just three different types of the height. Okay, and then actually the height is fixed, but we have to calculate the height including the volume of water level. Okay, so it's actually the data is quite complicated, but actually the procedure is where not to say it's very easy, but not complicated. Okay. Okay, so as you can see, we repeat it with H2 and H3. We have shown you in the picture the height of H2 and also the height of H3. That's how we run the entire experiment and then how we repeat the experiment. Okay, so I guess that's all from me for the methodology part, and I hope you guys like it because this actually is the last, I think, last experiment for the entire Cent 3. Okay, yeah, so that's all from me. Thank you.
So, hi and Assalamualaikum. Thank you, Tunruli. My name is Fiona Adrina, the group leader for this experiment. So now we will proceed with the result and discussion. But first of all, let's look at the result. Basically, in this experiment, we use the three height difference. So for the first one is when the height from floor to orifice is 36.65. So basically, this is what data that we have recorded. Then we have a volume of water, initial water level, maximum water trajectory distance, time taken for water to drain out, water flow rate, and velocity of water. So from the experiment, we can see that we have repeated this experiment for 3 times to get the average result, which is more accurate. So when the volume of water is 2, the initial water level is 0.76, the maximum water trajectory distance is 0.99 meter, and time taken for water to drain out is 10.09 seconds, and the water flow rate is 1.98 times to the power of 4 meters squared per second. And the last one is the velocity of water is 0.075 meter per second. So for the next one is the result obtained when the height from floor to orifice is 56.45 centimeter. So this is the result. And the last one is the result obtained when the height from floor to the orifice is 76.15 centimeter. And then we will move on to the discussion. For the first question, explain your selection on dependent, independent, and constant variable. So basically, dependent is what we want to observe. The independent is what we keep change during this experiment, and constant is what we always keep the same on this experiment. So the dependent one is maximum water trajectory distance. So basically, we want to observe the maximum water trajectory distance. And the independent one is the height of fluid. And the last one, the constant, is the density of liquid or density of water. So the choice of this variable is to fulfill the objective, which is to verify Torricelli relationship by comparing the measured and theoretical value of velocity. And then for the second question, clarify on how you can relate the Bernoulli equation with Torricelli law for this case. Show all the derivation and explain each step. So basically, Torricelli law may be derived from Bernoulli principle and relates to the velocity of fluid, leaving an orifice in a fluid filled container to the height of the fluid above the orifice. Then Torricelli law is derived from Bernoulli equation by equating the potential energy in the static head of liquid to the kinetic energy of the water, living through the orifice as follows. So basically, this is the Bernoulli equation. So we have the pressure 1 over density times gravity plus velocity 1 to the power of 2 over 2 times gravity plus Z1. Z1 is the height equal to the P2, pressure 2 over rho times gravity plus V2, velocity 2 to the power of 2 over 2 times gravity plus Z2. Okay, so we know the pressure P1 and P2 is atmospheric pressure, which we can indicate it is 0. Then V1 is also 0 due to the movement of fluid is small. Then Z2 we take it as the point of the atom, which will make it 0. So basic. Okay, so P1 is 0, V1 is 0, and P2 is also 0, and Z2 is 0. So we have Z1 is equal to velocity 2 to the power of 2 over 2 times gravity. So then we make this equation in terms of velocity. We get V2 is equal to the square root of 2 times gravity times with the height. So this is how we can derive from Bernoulli equation to the Torricelli law. And then the third one is percentage of relative error for the theoretical and measured experimental value. So to calculate the percentage error is V theory minus V experiment over V theory times 100%. Okay, then to calculate the average percentage error is the total percentage error over 5 because we have 5 data, and then to calculate the V theory we use this formula, square root of 2 times gravity times with height. And then to calculate the velocity of measured or experimental value is x. X is the maximum trajectory distance times square root of 2 gravity over 2 times y. So for table 1 is the result obtained for the height from floor to orifice is 36.65 centimeter. So when the initial water level is 0.76, the maximum water trajectory is 0.99. The theoretical velocity is 3.86, measured velocity is 3.62, and the percentage relative error is 6.22. So basically, we use the previous formula to calculate all of this. Then we get the percentage error for the first one is 6.22%, second one is 7.56, the third one is 19.46, the fourth one is 37.17, the fifth one is 75.64. So basically, the average percentage is we will total up these 5, and then we will over 5, we get 29.26%. Therefore, the second one is table 2. The result obtained for height from floor to orifice is 56.45. So for the first one, we get 48.96%. The second one is 39.12%. The third one is 25.75%. The fourth one is 8.67, and the last one is 10.78. So the average percentage is 26.66%. And then for the last one is the result obtained for the height from floor to orifice is 76.15 centimeter. So for the first one, the percentage that we get is 73.26. The second one is 62.5. The third one is 52.1. The fourth one is 31.33, and the last one is 10.74. So we total up all this percentage, and over 5, we get 45.99%. Okay, then for the source of error, okay, from the percentage error, from the average percentage error, we can see that we can conclude that there are some error when we carry out this experiment. So one of the source of error is parallax error when taking the reading for the height from flow to the orifice and initial water level. So to minimize the error, make sure that ice is perpendicular to the scale of reading when taking the reading. So perpendicular here means that when we taking the reading, our eyes must be in the same level with the scale of reading. And then the second one is the leakage from the cylindrical tank. We know that the leakage will cause the velocity, will affect the velocity in this experiment. So we must to make sure that all apparatus are in good condition before we use. This means that we need to check first either this experiment is good to use or not. And then for the recommendation, so the first one is to get a better accuracy of reading. Repeat the reading for 3 times and calculate the average of the reading. We know that taking one reading is not enough. So basically, to make this experiment more accurate, we need to carry out this experiment around 3 times to get a more accurate result. And then the second one is place the cylindrical tank at the end of the clip so we can get more accurate reading of this tank. So basically this point indicate that it is much more easier for us to measure the distance or to measure the maximum trajectory distance. Okay. So that's all from me. I'll pass my presentation back to Patricia. Thank you.
Thank you to my teammates. So now I will conclude this experiment. As the conclusion, Torricelli's law can be derived from the Bernoulli equation, and the relationship between the exit velocity and height can be shown from the experiment. As the height of the water in the container decreases, the exit velocity decreases too. This is our reference for this experiment. So I think that is all from us. Thank you.